Welcome to the Intuit Dev channel. I'm Lucy Shen, a developer advocate here at Intuit, and I'm here today with Manish Bhatia, a principal software engineer, as well as our creator and maintainer of the Fuzzy Matcher open source project. So Manish, can you tell us a little bit about Fuzzy Matcher and what it is used for?
Hey, Lucy here. Thanks for having me. In programming language, you always have equality checks between different types of data that you have, but you never have if data is similar to the something else. So that's what fuzzy match solves. So if you have data in real life where you have one record called Stephen Wilson living at 45th Avenue, you have another John Doe living at 546, and then you have another Stephen Wilson. So you can see there is similarity. Any human would be able to see that this is similar, but computers are not good at catching that. So what fuzzy matcher does is able to easily take any records that you have, find similarity, and give you a way to measure it.
So for example, if I owned like a candle shop and I was tracking my customers in QuickBooks, and I wanted to find a way to like create a grouping of similar customers based on maybe an address, I could use Fuzzy Matcher for something like that?
Yeah, very likely if you have a small business, you will have a husband coming to your shop, giving their name, and then you will have a wife coming to that same shop and giving their name, but they have the same address. So a fuzzy matcher will catch a similar address, will catch a similar last name, and tell you that hey, they are similar customers. You might want to link them together in some fashion, or in some cases there is same customer, and while at the time of data entry we just misspelled Wilson to Wilson, right? And it will catch that for you. Let me give you a quick example of how this will work in fuzzy match. So this is the same example that I put in over here. So if you are a Java developer, you're probably familiar in writing this in code. This is a list of data that I've just entered. And similarly, this is all you need to do to convert a list of records that you have and convert it into this for use of this library, and then call a match service. And if I just run this simple unit test, and you should see that it will match these three records. And if you see the output right over here, it says data Stephen Wilson at 45 Avenue Street matched with Stephen Wilson at 45 Avenue 5th Street, right? With a score of 0.875. So it kind of caught similarity and gave a number that you can see are they similar. If some records fall below a threshold of 50% similarity, it won't even show you, but all of this can be optimized for your use case, and very simple to use. With few lines of code, you can catch duplicates data in your system.
Awesome. I love how simple this demo is. So if anyone watching this wants to go try it out, go ahead and hit the URL in the description of this video. You can download or fork the repo and just go ahead and start using it from there. But if you're interested in getting involved and also contributing on the open source side, stick around a little bit. We're going to go into detail with Manish on like how Fuzzy Matcher works actually, into the technical architecture of it all. So Manish, the repo README actually has a really great graphic explaining how all of this works already. Would you mind walking us through it?
Okay, so Lucy, this is the 4 stages of fuzzy match that you called out in our GitHub, and it is fairly simple. The first step is pre-processing of any data. So the code example that I just showed, once you have an input in two sets, right? So any record is called a document over here, and every single part of that record, right? For a name, email, or an address, they are called elements. So once you have your records converted into a document and an element, the first step is pre-processing, and it is very simple. There are a lot of already inbuilt functions that does that. So pre-processing step is all configurable. These are all Java functions, so you can use any of these built-in functions, which are way more than what I'm showing over here, or you can pass in your own Java function, and it will just run it. So it is highly configurable to use any of them in your use case. But we create sensible defaults. So all we ask for the input is what you're trying to match. So if you're trying to match a name, you will have different defaults than if you're trying to match an email. You will have a different defaults that are already set in. So all you have to say that, hey, I'm trying to match an email is an element, and it will take an email pre-processing step. But if you have your own set of data that doesn't fit well over here, you can write your own function. And the next step is tokenization. So once you have the pre-processing done, it will then break down the elements into tokens. And these tokens again differ on the type of data that you are trying to match. So in case of names that I just show, Stephen Wilson and Stephen Wilson, we use something called SoundX token. It is a phonetic match. It's a library already out there from Apache, open source library that we use. We will convert every single word into a SoundX token. In case of in other cases, like for example, email that I just spoke about, it's difficult to break it down into words because email usernames are essentially one single big word. So we use ngrams tokens where, for example, if J Parker is a kind of a username, it will be broken down into trigrams. This is an example that I'm showing over here. So in that way, in some places, it is essential to match a character level match, and in some cases, the whole word could match. In cases of numbers, you don't need tokens. If you're just matching a phone number, you don't need to tokenize it at all. So there are sensible tokenization again set over here, just like pre-processing. There are a host of library that you can reuse or pass in your own function, and it can do tokenization for you. Once your tokenization is done, then the rest of the step is actually quite simple. Is match, and the two sets of match that we provide out of the box is equality. Is one token equal to the other, or in case of numbers, it's the nearest neighbor. Is 10.23 kind of equal to 10? And this is very useful in case of transaction matching, right? So you got some dollar amount from somewhere, somebody entered a decimal places, and sometimes you don't care about that. You just want to know what is the dollar value and if it matches. Similar with dates, right? Sometimes you have dates with long timestamps and time zones attached to it. Sometimes you don't. So those kind of matches is useful with nearest neighbor. Once you have all the match, the rest is essentially rolling up and score. So this would take every single token that are matched and roll it up and give you a total score at your document level. And again, there is a sensible set of libraries available over here, which does this rolling up and score, and new ones can always be created over here. So this is, yeah, the four steps of a fuzzy match. It's a really simple library to use. If you just follow this pattern, you can basically match any kind of data.
All right. Thank you, Manish, for walking us through the 4 steps. So obviously there's a lot of features that are part of Fuzzy Matcher. We have exact word match, ngram token match, nearest neighbors, right? If you want to read up on all of this, it's all in the README, in the repo. So go ahead and check it out. Again, the link is in the description. And Manish, if people want to get started with Fuzzy Match, I remember you said it takes like less than a minute. Could you walk us through how you do it, starting from the cloning?
Oh yeah, yeah. So this is a simple library. All you need on your machine is have Java 11 installed and Maven installed. If you already have that, for most Java developers, that should be a sensible defaults to have on your machine. You can just clone. It's a very lightweight library. It hardly took some seconds to do it. Once you have this downloaded, go to Fuzzy Match, and just like any other Java package, just run Maven clean install, and it will start installing it in your machine. Once it starts building, it will start running some tests. Most likely, if you have records to be matched, you're not going to be matching 3 records that I showed in the demo. It's going to be in thousands, right? So it is running a unit test of 2,000, 4,000, 6,000, making sure that the time it takes to match any of this is reasonable. There you go. So build was success, and you have the entire code base over here. There is easy contribution steps over here. We can go through the steps. It's very similar to what I just demoed. Just make sure you have Java installed, Maven clean installed. That's all you need to run, and that's it. And then there are contribution guidelines for doing pull request, and there is a community of members who will take care of the pull request. If you have any questions on how it works, there is an issues that you can open in the GitHub, and again the community of developers that we have are very quick to respond to it, and you should get your answers really fast.
Awesome. Yes, we're absolutely looking for more contributors, more maintainers, right? So if you're interested in getting involved, this is a perfect library to get started in. So do check out the links in the description. We also have an Intuit open source LinkedIn community that you can join if you'd like to get involved on that side as well. Thank you, Manish, for showing us the ropes and walking us through Fuzzy Matcher.
Thanks, Lucy.